Did you know that Indonesia has been the world's #1 producers for crude palm oil since 2013 and until now? But unfortunately, only 20% of it has been already processed into a product with higher added value and being sold back in our country, while the rest 80% is being directly exported to other countries. So I, Alika Fadia Rahmi, as Mawapres ITS delegation from Chemical Engineering Department, is proposing a new idea for an independent Indonesia. So my idea is to utilize crude palm oil and process it into a high-value product, which is a mechanical lubricant. Recently, it is already known that crude palm oil could be processed into mechanical lubricant by using a homogeneous acid catalyst. But this homogeneous acid catalyst has several disadvantages because it is hard to be separated from the product when the process is finished. So here I am proposing a new idea of using a heterogeneous catalyst. This solid catalyst could be reused for further process. So if we are using it in the industry, it is very simple and it is very practical for us to reuse it, and it will save a lot of cost and operating costs for the industry itself. So it could be easier if we want to separate the solid catalyst from the lubricant, which is the product that exists in liquid phase. And moreover, the solid acid catalyst is reusable because it is solid, that it is easier for us if we want to reuse it for the further process in an industry. For example, if we are running an industry, it will be very easy for us to regenerate this catalyst and reuse it for further process, and it will be very cost saving in terms of operating cost. In addition to that, this liquid phase acid catalyst is potentially causing corrosion because it exists in liquid phase and it is hard to be separated from the final product. Therefore, it is highly undesired for us to have a lubricant that is corrosive for the mechanical material. Then, it is necessary for us to create a catalyst which is easy to be separated from the final product, and also it is not corrosive, and it is the solid acid catalyst. In this research, water glass is being used as the source for the silica, and template PEG is being used to enlarge the pores of the silica itself. Why it should be enlarged? Because we need a high surface area of the catalyst so it can work properly and it can work effectively to conduct the process of converting crude palm oil into lubricant. Although this PEG template is being used to enlarge the pores of the silica, but we don't want this PEG template to be contained in our final result of the catalyst. Therefore, we need to remove this PEG template from the surface of the catalyst. In this research, there are two methods that we use to eliminate the PEG template from the catalyst. First is the calcination method, and the second is the sulfothermal extraction method. The results obtained from both methods are actually equally effective to remove PEG template from the catalyst, but it was found that by using the calcination method, the catalyst tends to shrink, and when the catalyst tends to shrink, it means that the catalyst is losing its high surface area. Therefore, based on this research, it is concluded that using the extraction sulfothermal method is better compared to the calcination method in order to eliminate the PEG template. The other important aspect to be assessed is the ionic capacity of our solid acid catalyst. We need to ensure that our ionic capacity is approaching the homogeneous catalyst ionic capacity. If it is approaching that, it means that our solid acid catalysts have as good performance as the homogeneous catalyst to process crude palm oil into lubricant. It is found in our research that the ionic capacity of the solid acid catalyst is approaching the ionic capacity of the homogeneous acid catalyst. Therefore, it can be concluded that our research has proved that this solid acid catalyst can replace the function of the homogeneous acid catalyst to process crude palm oil into mechanical lubricant. I believe that this research will provide the best solution for Indonesia to improve their production of crude palm oil into another product which have higher added value such as mechanical lubricant.